Okay, the second half of section P2 deals with radicals. And the reason why exponents and radicals are grouped together is because a radical is just an expression of a fractional exponent. So we need to remember that that's how those are related. Keeping in mind the fact that because radicals are just fractional exponents, that all of our rules of exponents can apply to radicals as well. So we need to remember that if we have an exponent written as a radical, so for example a to the 1/2, we can rewrite that as a radical a, and then it's just a matter of remembering where your 1 and your 2 go. Your 1 is still your exponent, and your 2 is your number outside your radical. Now typically you would not express this 1 as a to the first power, we know that. And you would not necessarily express that 2, because we know that's a square root, which is typically just written as the square root of a. Okay. Now, some more general formulas. So if we have a to the n over m, how do we rewrite that in radical form? So again, we're going to have our radical. A is underneath the radical, and it's a matter of remembering where n and m go. N is still your exponent, and m would be on the outside. So if you are asked to change something from radical to exponential form, or vice versa, you should be able to do that. So we've got 2x times x, the fourth root of x to the third. So we need to rewrite that in exponential form because this is already partially in radical form. So we're going to go ahead and rewrite that so it's in exponential form. And as soon as you see a radical, then you should be thinking, I should have a fractional exponent. So 2x I can't change yet. So we've got 2x, and then this fourth root of x to the third. X is my base, and then I know it's going to be a fraction, and then I need to remember where the 3 and the 4 go. Remember, 3 is still my exponent. Okay. Now, remember at the beginning I said because radicals are just a fractional exponent, all of our rules of exponents should apply. So I should be able to simplify this some more because this is 2x to the first power and then x to the 3/4 power. 2 bases being multiplied together, so I should be able to add these exponents. 2 I can't do anything with, but that should become 7/4. So you should feel comfortable translating back and forth between radicals and exponents. Okay, something else that we need to remember, your book talks about this on page 21, about halfway down. And I'm just going to read directly from there. So if you have your book open, that will help. It says radical expressions can be combined, meaning added or subtracted, if they are like radicals. That is, if they have the same index, so that would be the number outside the radical, and radicand, which is a fancy word for the number or variable underneath. Okay, and then if you look, example 16 goes through some of these problems. A deals with just numbers and B deals with some variables, noticing that you can't add or subtract them unless they are the same number underneath the radical and the same number outside the radical. Okay. So, page 21, example 16 is important. I'm going to go ahead and work through A. 2 square roots of 48 minus 3 square roots of 27. And we are trying to subtract these. Now, as it is right now, I cannot do that because this is a 48 and this is a 27. Now, they have the same index. It's a 2, just not written there. Okay. We'll wait for my phone to stop ringing. Now might be a good time for you to pause the video and see if you can do this problem by yourself. We need to get these numbers underneath the square root to be the same. So think about how you learn to simplify radicals. Okay, so simplifying radicals. This is a square root. This is a square root. So I need to think about numbers that are perfect squares that would multiply to get 48. Because if it's a perfect square, then I can take it out of the radical. So I could rewrite the square root of 48 to be the square root of 16, because 16 is a perfect square, times 3. Minus 3. 27 I can break into 9 and 3. So, you can also break things underneath the radical apart. So it would become like that. Minus. Now, so all I did was break about 27 into 9 times 3. When you have things underneath the radical being multiplied, you can break them into separate things. Okay? And then here, what's the square root of 16? Well, that's 4. So I've got 2 times 4 times the square root of 3 minus 3 times the square root of 9 is also 3. Square root of 3. So I have 8 square roots of 3 minus 9 square roots of 3. And now that those numbers underneath the radical are the same, I can actually perform this operation of subtraction. So 8 square roots of 3 minus 9 square roots of 3 would be negative 1 square root of 3. Or you could just say negative square root of 3. Okay. If you don't remember how to simplify radicals like that, you might want to think about doing a little bit of extra practice with those. Last thing that this section talks about is rationalizing the denominator, which is something pretty much from this point on you're going to be expected to do. So, that means is if you have a fraction, you should not have a radical in your fraction, in the denominator, of your fraction. So, I have 5 over the square root of 10, and I shouldn't have that square root of 10 in my denominator. So, I'm going to rationalize. Hopefully, that word is bringing back some memories. So, I should be multiplying by square root of 10, square root of 10. 5 times the square root of 10, I can't really do anything with. So I've got 5 square roots of 10. Square root of 10 times the square root of 10 would be the square root of 100, which is 10. Now, what you need to think about is this is really 5 over 10. So I should be able to simplify that as the square root of 10 over 2 because there's a 1 in front of here. The 1 is not necessary. Okay. The other thing at this point you would want to make sure is that the square root of 10 cannot be simplified, meaning that it doesn't have any perfect squares. Square root of 10 can't rewrite it as anything with a perfect square. Second way to rationalize the denominator would be if you had 2 terms in your denominator. So this was a single term. We've got 2 terms. So now we need to multiply by the conjugate which is our denominator with an opposite sign. Okay, so if you notice, the bottom is going to become a FOIL problem. So we've got two terms being multiplied by two terms. The top is just going to become distributive property, and we're going to have lots of simplifying to do. So I would suggest at this point pausing the video and seeing if you can finish this problem on your own. I'm going to go to a new piece of paper. So we've got 5 times the square root of 14 on the top. Can't do anything with that. Plus 5 times 2, 10, over. Like I said, this is a FOIL problem. So first would be square root of 14 times square root of 14, which should just be 14. Then square root of 14 times 2, and it's positive, so plus 2 square roots of 14. Inner would be a minus 2 times the square root of 14. Okay, and then my last would be negative 2 times positive 2, so minus 4. This is good news right here that these two middle terms are going to cancel, because remember, my whole goal is to get rid of the radical in the denominator. Simplify, I've got 14 minus 4, so that should be 10. You might look and see that this can be simplified as well. So this is going to become 1, 2, 1. Square root of 14 plus 1 all over 2. Okay. So this concludes section P2.